The data from the Landsat Data Continuity Mission will be the best data that have ever been collected from a Landsat satellite. With increasing population, our land use are changing at rates unprecedented in human history. To manage and cope with these changes, we need to have the observations, the information, the data that allow us to understand what's going on the surface of the Earth where most of us live.
Landsat's been monitoring the surface of the Earth since 1972, tracking resources like farms, forests, and water, and checking every continent, every season, every year.
Well, we don't call it the Data Continuity Mission for nothing.
The continuity of those observations is a really critical part of the ability to do the science we do on how climate change and how land use are transforming our planet. The Landsat program and the duration of the Landsat time series is the only record we have of these fundamental changes in land cover, including melting glaciers, including the loss of tropical forests, including the transformation from small-scale family agriculture to large agribusiness.
After launch, LDCM will become known as Landsat 8, since it's the 8th in the Landsat program, a partnership between NASA and the U.S. Geological Survey. NASA is responsible for building and launching the satellite, and the Geological Survey is in charge of operations and receiving and archiving the data. LDCM carries 2 instruments, each covering a different part of the electromagnetic spectrum.
The OLI instrument monitors the Earth's surface in spectral wavelengths that you and I can see in. That's the visible wavelengths, and also just into the infrared regions, the near-infrared and shortwave infrared regions.
The operational land imager is used to track urban sprawl, forest loss and regrowth, changes in farmland, and the melting of glaciers.
The thermal infrared sensor instrument, TIRS, monitors the Earth in thermal bands, it actually images temperature on the Earth's surface.
With TIRS, scientists are able to track how much water is used by crops on individual farm fields. And the new technology used in LDCM means that both TIRS and OLI will be much more sensitive than previous Landsat sensors.
The greatest improvement we've made in the LDCM satellite is that the sensors are what's called push broom sensors and not what was called whisk broom sensors. Push broom sensors have thousands of detectors that just image the Earth as the satellite passes over the surface of the Earth. The older Landsat satellites, Landsat 7, Landsat 5, use a whisk broom technology, which is many fewer detectors scanning back and forth with a mechanical scanner.
The advantage of the push broom is each detector has a longer time to dwell on each picture element or pixel on the surface of the Earth. As a consequence, it creates a sensor with a much higher sensitivity expressed as signal-to-noise ratio.
T-minus 5, 4, 3, 2, 1, and liftoff.
The LDCM Observatory launches out of the Vandenberg Air Force Base in California and launches into what's called a polar orbit. And so it orbits over the north and south poles, taking imagery on the sunlit side of the Earth every time it passes.
It takes about 100 minutes to loop around the poles. LDCM will make 14 orbits each day and cover the whole globe every 16 days. Every time they pass over the U.S., Landsat satellites beam data to the USGS Earth Resources Observation and Science Center, or EROS, in South Dakota, one of several receiving stations around the world.
This center operates the Landsat archive that contains all of the U.S.-held data from all of the Landsat satellites, and the LDCM data will become part of that archive.
All of the data in the Landsat archive at EROS can be obtained by anyone at no cost. This freely available data has led to an incredible blossoming of science research and applications.
My favorite part of the Landsat program is the opportunity to think big. With free and open access to data around the world, we're not limited as we once were in our ability to conceive of and analyze large data sets to look at really large-scale changes over continents, over the globe.